I'm just going to get the recording going. Okay. And so before we move on with the formal agenda for today, I wanted to open things up for anything Q&A, anything that we've covered. I know it's kind of maybe a mute point since we didn't meet last month, and maybe everybody's kind of forgotten about what we've done thus far in the group. But if there's any questions, comments that the group has for to before we launch into today's material.
I just want to mention that I'm attending from the annual Ham Radio Field Day event
Oh,
here in West Seattle. Uh, so I'm using Wi-Fi that is probably under battery power because the entire event is supposed to be under battery and perhaps generate.
yep. Well, yeah, those field days are fun.
Say, Doug, are you using a radio modem?
Well, I'm using Wi-Fi.
Yeah, right. Wi-Fi hooked to some, is it? Yeah, I think the bandwidth is kind of low on the ham radio data streaming, right?
Well, it depends on the mode. We have repeaters in the area that will give you video data rate. If you want to get into that kind of stuff, I'm not into that myself, but yeah. So it's pretty noisy around here. We've had people demonstrating digital modes to speaker, and so we'll see how well we do here attending the meeting.
Yeah.
Okay, very good.
Okay.
Okay, so anything on point as far as the Arduino group that we want to discuss? We're just kind of opening the floor to any logistics or follow-up questions from previous sessions or comments from those. Anything that to bring to the floor?
Don't think so.
Okay. Okay, all right. So why don't we go ahead and get started for today? Let me go ahead and let's see here. Do share screen. Okay. All right. So can everyone see my my beautiful slide there? Okay. So welcome everyone to the June 28th issue of the monthly Build It with Arduino Meetup Group. Glad you guys are here. And so just general statement about online recording. I am currently recording the session. And the idea is that if there's any issues that you personally have with being on video, being recorded with your audio, then I ask you to handle that appropriately. And because the idea here is that we want to learn and share together, and those of us or those people who are not present here today, they still have the opportunity to consume the resources and materials offline via Discord and the YouTube channel. So I automatically upload these recordings, etc., onto those assets for later consumption. And just general for code of conduct, the official copy of the document is on the Discord server under the pound rules channel. So you can get more details there. And basically all of us, including myself as the host, the expectations is that we be respectful with everyone, use short and to the point questions and feedback. And for any of us who are speaking, please don't interrupt the speaker. It's just a nice politeness. This allows for a safe and fun learning experience for all of us. Okay. All right. Okay, I'll go ahead and stop the. Okay, so stop share. All right. So let's go ahead and get started with the actual education content that I wanted to cover today. Let's start with shields. Okay. Let's talk about what a shield is and some of the choosing wisely advice that I have on shields. So first of all, what is a shield? It's a stackable board in some sort of arrangement and footprint size that literally plugs via the header pins, plugs into the top of your choice of Arduino board. It's the idea of it provides additional features that are not by default part of the Arduino board system that you currently use. So it's a way of extending either programmatically or function wise the features that are on the Arduino itself. And the usual forte of a shield is that it's functional specific. So if we're talking about SD card functionality, it'll just be that SD card function that's on that board. If we're talking about motor control, like DC or stepper or servo motor control, there's usually one of those that's associated with the function that's on that board. And as I say, it's the design. You don't necessarily always have to mount things that way, depending on what your form factor is for your contraption that you're building with Arduino. But the usual is that it's a push on, pull off kind of scenario for the way that the shield fits on. Okay. Now, you likely hear all over the place, Arduino land, this concept of shield. And you may also hear a term that is more Raspberry Pi centric called a hat. It's literally the same concept. It's just that Raspberry Pi has their own term. So there's hats out there and there's shields. So so that's what a shield is. Now, compatibility wise, and we're going to get into a little bit of a show and tell and my guidance as far as what to look for with a shield and the gotchas that you may encounter whenever you go to purchase a shield and then whenever you go to plug it in and actually use it. Because there can be pin conflicts depending on the particular, a lot of these shields, well, most shields are not agnostic across all the Arduino boards. Remember early on in these sessions, we talked about the huge number of Arduino boards that are available, both size and functionality wise, all the different features that can come on a particular Arduino board. And most of the time, shields don't fit for any Arduino. Okay, they're usually just a small subset. Say, for instance, on the lower end of Arduino boards, if we're talking about Uno or we're talking about a Mega, usually they're just specific to those versus the higher end, more expensive Arduino boards that are out there. So that's one thing to note is, number one, what is your board that you want to find a shield for? So you always have to look at that in the specifications for the shield. You also want to make sure that the pins that you will be using for that shield are not being dedicated to another function that you're using with your hardware and software solution on the Arduino board itself. In other words, pin conflicts can interfere with what it is that you want to use the shield for. And as I say, the idea said before about shields is that physically via the I/O headers that are on the shield itself and then onto the mating Arduino board, it's an I/O headers kind of physical compatibility that needs to occur, and versus the other concept that you could use with a shield as far as literally mounting that shield board off of or separate from the Arduino. So you can do it that way. It's just it's not the default way to use a shield. Okay, so evaluating quality of shields, and we'll get into some specific examples here in just a minute. You want to look at the documentation that's available for a particular shield. How well documented is it? Is it easy to understand what the way to program it and use it, and also to interface with it in a hardware standpoint? So that right there, I think, is really key. You want to look at manufacturer credibility and available support from that manufacturer. Now, I'm talking about manufacturer here. I'm not talking about distributor, retail distributor that you buy the board from. I'm talking about manufacturer credibility. Availability of example code and libraries. That's key. In other words, you want to know how to really use the board with ease. And you need to scrutinize the specs. I already talked about that. You need to confirm compatibility with your hardware, such as which Arduino or Arduinos are supported. You want to look at the connectivity requirements, like I/O and power, battery power needs, all that, and the functions that are provided in the libraries that you're going to be using. So that's all important. Now we're going to do just a little tiny mini show and tell of some shields that I want to talk about today. Let me get my show and tell box out here. Okay, so over the years, some of these were bought before I really knew what I was doing with purchasing shields. I mean, let's be transparent here. One of the very first, early on, when I was first getting started with Arduino, I wanted to have so there's tons and tons of shields out there, basically for most anything that you want to do as far as extending capabilities of an Arduino. You're going to be able to find a shield for it. And so you need to tread with discretion as far as ultimately which one you want to go with. So I decided to go mostly for the idea about economy of price. One of the things that I wanted to get for my Arduino use was a way of having like a breakout board for easy plug and play sensor and I/O connections on that sit on top of the Arduino. And I purchased the manufacturer of this board is Get Fun, GIK, and then the word fun sensor shield. Okay, and so I thought that it was going to be fully compatible per the detail that was available for the board with either an Uno or with a Mega, because those are the two primary Arduino boards that I was then and are currently using. Anyway, so after I received the boards, there were a number of problems that I found with it. Number one, the quality of the manufacturing was low. After I dug in closer to the specs, I found out that it's not compatible with the Mega. Remember I talked to you about the pin incompatibilities and all that? Well, anyway, so it just turned out to be an Uno only specific board. So it very, very low quality for this particular product. So something that, and this is like an overseas, like China kind of thing, is where this came from for the manufacturer. So even though something is cheap for a shield or some other kind of sensor, buyer beware is what I'm getting at. So that's something that was a hardcore learning that I had. In general, I recommend high quality distribution houses for your electronic parts. And the reason I say that, like for instance, Pololu, Parallax, Adafruit, Seed Studio, and the official Arduino store are great retailers to buy good, high quality, in general, good, high quality components from. And the reason why I recommend those is that you circumvent a lot of these problems, like with this Git Fun board. I bought that outside of those sources that I just talked about. So that's a good thing to be thinking about. And you can buy these shields either as a kit, where you literally get the raw board and you got to do a bunch of soldering assembly. But most of them are fully assembled. So that's always, that's something else you got to think about whenever you're shopping and you're actually making your purchases. So some other examples I want to talk about as far as quality and function is I find that Seed Studio is a really good product. And this board that I'm showing you right here is a DC motor shield. And so this is a really, really good one. It comes with a good Arduino compatible library and great reference material on how to use it. So Seed Studio, I think, is a really good one. So that's one right there. And another great Seed Studio Shield product is for SD cards, for doing file read and writes to plugged in SD cards. What's great about this particular shield is that it accepts the old style SD cards as well as the micro SD cards. So you can not use both cards at the same time on the shield, but you can choose which one you want. And it's, again, great library to make the reading and writing of your file system that is provided by this board on the card. It makes it very, very nice and simple. So that's a great product. Another, I mentioned about Adafruit. Another shield that I like is providing GPS compatibility for your Arduino. And it's called, and I'll be putting the links and everything available later, okay? But it's called Ultimate GPS Logging Shield. And this is one of those where it comes in a kit form. So what I love about this particular product is that it comes with a really, really great full function library. That the library, as far as libraries that are GPS specific, can be all over the map as far as something that only provides basic what's called NMEA sentences, which is what GPS is based on, for the data that's received into the receiver, which is what's included on this board. Most libraries only do that reading, that parsing that way. They don't provide any other logic functions, which are great in my book in combining robotics along with Arduino, as far as providing navigation information, nice functions to enable navigation based on GPS data. And so the library that comes with this product is fantastic that way. So that's a great product for you to consider. Also, Arduino wise, I talked about the idea about like an IO breakout board. this Arduino product called the Proto Screw Shield R3 kit. Again, this is another kit product. It allows for easy I/O access directly separate from the Arduino board itself. So this is another great product. And then lastly, for what I wanted to share about show and tell for shields is Pololu is another great retailer. Very good, high quality, both in terms of documentation and quality of manufacturing. This is on the DC motor driver side of the house. But there's a Pololu dual motor driver shield for Arduino. Again, this is another kit. The only caution point for those of you who are not familiar with buying Pololu products, the only negative that I have found with Pololu is their user manual documentation. The only thing that's bad about that is that the documentation that they produce, they don't segment it out by part. They put a whole bunch of different parts that have similar functions all within one document. So it can be hard to parse out for your one board or your one sensor, your one part that you want to find documentation on. It can be hard to parse everything out. Well, what is it in this document that really applies to what it is that I want to work with? So that's really the only negative that I personally see with Pololu. Yeah, so that's what I wanted to say about shields as far as the show and tell part of that. So is some other general guidance that I wanted to talk about in finding what you really want for an Arduino. I recommend doing like a Google search for Arduino shields, both the shield itself and then for libraries or code examples. And just note all the confusing array of what's out there. So let's go ahead and do a comparison about motor shields, okay? Just as a starter point here. Let's see here. Just going to do that. Okay. Nope. Okay. Okay, so can everyone see my browser screen? Okay. Vincent, can you guys see my browser screen?
Yes.
I've got a little. Okay, great. Okay.
Yes.
I'm going to make sure that share screen was working. Okay, so let's do a compare and contrast regarding motor driver shields. Okay, so I've got two of them up here. Two of them that were part of my show and tell product line here. I've got one here that's a Pololu product, and then the other that's a Seed Studio. Okay, so let's talk a little bit about what I recommend, the way to evaluate. Because with all the huge array of shields that are out there, for any one function that you want to buy a shield for, you're likely going to run into 3 or 4 that would potentially fit what you want. And how do you make the ultimate choice other than, of course, price and quality from what you can see for the quality of it? How do you choose on functions and making your final choice? Okay. So you want to of course you want to read. So this is one of the great things about Pololu is in addition to the user manual that is usually available. Well, it's always available in their resources category. Like for instance, here's the user guide. Okay, for this particular product, they provide data sheets. They provide the Okay, so here are the Arduino, or excuse me, the libraries that are available. Okay. And so a lot of times, so you want to look at the array of available documentation. You want to look at the credibility that you can see for that particular product. You can even do some online research as far as successes and fails, and warnings of get, oh, don't buy this product, or so those types of things you want to look at. um and you want to review a little bit before you make your purchases. Well, how usable is this shield really going to be for me? So you want to dig in a little bit. You want to download like the library or libraries and look a little bit at the code that's provided there. You definitely want to look at the user guide, the documentation that comes with it. So that type of thing, and then any warnings that you find online about the credibility of the product and how well it will perform as advertised, that type of thing. You want to look at for motor drivers, you want to know what it is that you're interfacing to. We're going to be getting into exercises and projects on that starting next month with the announcement that I've got for our group project. And one of the main things we're going to be starting with is interfacing motors, DC motors, in with Arduino. And so you're going to want to get ultimately or intimately familiar with motor driver shields. So you need to know your motors that you are going to be interfacing to. You need to know the voltage specs. You need to know the current draw, and details like that. And then also the power requirements, aside from voltage supply of the motor itself, that's required on the shield. Typically, these shields come in a 3.3 volt board supply or 5 volts. So you need to do like an engineering match game as far as finding out and doing a detailed plan. Well, how is this shield really going to fit for what it is that I want to use it for? But as I say, you really can't go wrong with a Pololu product, and that includes with shields. So if all else pans out for the specs for your DC motor in this case, then I would say, and the price is okay. That's in this case at $79.95 for a product purchase of one. Then you're good to go. The other thing for DC motor shields that you want to look at is a lot of these boards, they can control independently 2 motors or just one. Now, in this case, this is a dual motor controller. So that's really nice as far as the DC functionality, DC motor functionality. Okay. So I think that's enough said on that particular Pololu board. I was talking about this Seed Studio product, this shield, okay, this motor controller shield. The only real negative here, if you're comparing this guy to that Pololu board, is that this only interfaces to one DC motor. I think that's a true statement. But what's, then it does support up to 14 servos, which is a nice addition. And I don't think that the Pololu board supports that. So these are the types of things that you need to look at. You need to, sure, people go all the time, builders, designers using Arduinos, etc., and they just willy-nilly buy some products. But if you're on the monetary side, you want to be careful. You want to use good engineering judgment, know what it is that you're buying, make sure of what you're getting. So I talked to you about some of the great features with Seed Studio products is they easily detail the specifications out here for you. on their documentation pages. They show you amply of how to connect in a hardware sense to the board, and some of the cautionary points in using it. Those types of things. They talk about the in great detail all the indicator, the meaning of the various indicators that are on the board, and the way to ultimately, in a hardware sense, connect and use the board. They talk about, anyway, I won't go into any of that anymore. Oh, it does look like this board supports 2 DC motors. Okay, so I connect DC, or maybe it is just one. Anyway, I forget which is which on that. Oh yeah, so it does show 2 here. Okay, so it will work with 2 motors. Anyway, that's some advice that I've got as far as looking at the DC motors, the specific shields for that. And as I say, you really need to know what you're going into ahead of time for this particular type of shield, in that you need to know if you're talking about DC motors, stepper motors, servo motors. You need to know, especially for DC, what the specs are for that motor. So that's all important stuff. Okay. All right. So enough said on that. Okay. So I'll go ahead and stop share for right now. Okay. So we'll be opening things up in a little bit as far as for questions, as far as anything that I've talked about so far today. But let's move on to the next agenda item. Okay. Where we're going to talk about pre-written libraries that you can use with an Arduino. Okay, so we talked about pre-written libraries in a previous meetup meeting a little bit, but in this section, we're going to go just a little bit deeper, okay? So that you can figure out what you want to use for libraries. Okay, so where libraries come from. By default, Arduino.cc provides in their Arduino IDE a huge subset of libraries that are compatible. And it's called the IDE Library Manager. Okay. And so you'll find the majority of what you want to use, unless it's something specific with a off-the-cuff manufacturer, you'll usually find what you want off of the library manager in the IDE. Another spot where libraries are found, downloaded, and sourced into your development environment are from GitHub or from manufacturer websites. So I showed you before about Seed Studio. Okay. So for instance, off of the Seed Studio documentation site, if you don't find that particular board from Seed Studio in the library manager, these credible board manufacturers will provide a hyperlink in there for the library code. So you can always do a download off of the internet if something is not available by another means. Okay. So that's either GitHub or a manufacturer's website. So there's lots and lots of places where you can find your board, your part that you want to use a library for, off of the different locations. Okay, so let's take so the main Arduino.cc website is docs.arduino.cc/libraries. And I'll show you, we'll do a little review on there in just a little bit. So if you are looking for something that is not provided in the library manager, like during your exploratory phase of figuring out what board that you want to buy, what sensors that you want to buy, and then trying to find a library that is already pre-written, you want to start with a Google search to look for that particular part or board. And then also manufacturer's documentation site, like what we were looking at there with Seed Studio. So you can 9 times out of 10 be able to find what you're looking for using those resources. Okay, so evaluation criteria. Just like with Shields, you want to look at documentation and examples. Regarding libraries, you want to look at actual use code examples in addition to documentation of functions. Again, we'll look at that in just a little bit, but that's what I mean by documentation. Code examples of using that library, and then documentation of the functionality and the overall warnings from the developer of that library of how to adequately and properly use the free library. You want to look at adoption by the community. In other words, we'll look into some actual examples of this, but you want to look for high level of community use, that the adoption of that library is commonplace. You don't want to go with something that hasn't been updated for a long time, nor used a lot. You want to look at the update frequency of the various versioning of libraries, how, the frequency of it, and also the maintenance. You want to look at bug fixes. You want to look at bugs that are reported for a library. You want to look at that the developer or developers of that library are getting in and maintaining that code base to fix the bugs that are reported. All that kind of stuff is so important when looking at software in general, and also hardware. Okay, so I want to talk a little bit about in my view, the 2 different types of Arduino libraries that are out there. In general, the whole idea of a software library is to have a lot of the low-level interfacing, a lot of the details to interface those key parts that are on the board or sensor to the Arduino in this case. In other words, that all of that I/O, the timing, the setup stuff is taken care of for you within the library. That's the whole goal. In other words, it's a programmer shortcut, especially if we're talking about a person who is not real used to computer programming, not used to Arduino programming. It's a very helpful case that you can utilize a good quality library and have those and make your coding easier, because you've got a reliable set of functions that you can rely on to use that board. So the low-level details are taken care of for you. That's the whole idea of the library. There are also examples of libraries that are out there that provide other features and services besides I/O and communication with a part or a board. Unlike what I showed you during the show and tell section for Shields and whatnot, there are also lots of libraries out there to provide a type of real-time operating system or a kernel that can run on one or more Arduino boards. That's an additional type of library that's out there. Or providing support structures as far as software architecture is concerned. For instance, providing finite state machine implementations, or way of incorporating multiple thread synchronization and all that. Those are more advanced topics on the software architecture side. But what I'm getting at is that libraries don't only have to be part or sensor specific. They can provide other type of support in a software sense to enhance what it is that you have on your Arduino board. So those are just some other types of library things that I thought that you should know about. Okay, so now we're going to do a little mini show and tell about comparing a couple of different Arduino libraries. Okay. Okay. Right. So I mentioned like in a minute or so ago about the docs.arduino.cc/libraries. This is the main, as far as the stuff, the libraries that are included in the IDE library manager. This is your source location to look at all that information. In other words, if you find what's that you are using your IDE and you find that there's something in there that you're not familiar with that's available directly in the library manager, you can go over to this site and you can start digging into the documentation and the uses of those libraries for what it is that you want to use in the IDE. So this is kind of your documentation headquarters, so to speak, for what is provided within the IDE itself. And so if we do, again, this is the general location for all of those libraries. And you can do a search for particular functionality and even for a library match for a particular part number or board number or a particular named sensor, all that kind of stuff. You can do you can do searches that way. So I remember I talked to you about GPS. Okay, so let's do a search on GPS and see what it shows. Oh, okay. Well, I guess we have to go with what's shown there on the. Okay, so let's do. Okay, all right. So on doc. Okay, so on docs means that there's documentation support for a particular library, and then in the library itself, I suspect that they're talking about the library manager, that these are the libraries that are automatically included in the current version of the IDE, the Arduino IDE, but I'm not quite sure on that. What I'm more talking about is documentation to compare libraries. That's what it is that I wanted to look at. Okay, so if we go through, see, look at all these different libraries that are out there that are only on the concept of providing GPS. So if you go through and you're looking at, well, let's see, I'm not gonna do it that way. I'm gonna go ahead and look at from the library side for GPS. If I go through and I look at the sentence parsing functionality for a GPS, there are two libraries that I want to talk about that. Hide the floating bar. Okay, one of them is called Tiny GPS Plus. What I'm talking about here is a board agnostic. I'm talking about sensor board now. Sensor board that provides, or shield, that provides GPS functionality. There are two libraries that are prevalent out there for doing GPS data or sentence parsing. And I wanted to take a little look at how you utilize this site for function such as this, as far as GPS. And so remember we talked about as far as some basic evaluation criteria. And you want to, well, ultimately what you need to do is do a review, really, with libraries out there as far as Arduino, since everything is open source. You can, once that you have your hardware in your hands and you have your Arduino that you want to utilize it with, in general, there is really no harm in downloading any one of these libraries and actually taking it for a test spin. A lot of times that's the only way that you're really going to be able to tell how usable that library is for your system. and how easily you can use it. Is it actually going to do what it says that it does? Is it going to end up crashing my Arduino? But what's usually great about software like this is that even if it breaks something, it's not a catastrophic failure. And so you can get in and you can install something, or you can uninstall something, and then you can try something different. So a lot of times that's what I recommend if you're evaluating something like this, as far as GPS sentence parsing, that a lot of times that's going to be the only way that you can really tell if it's something that's going to serve your needs. What's great with Tiny GPS Plus is that this is a library that's been around for years. The predecessor to this was Tiny GPS, and with Plus, it allows for other types. It does a more robust standard NMEA sentence parsing type. It provides more access into more of the standard sentence types, and it also reports on all the different types of location data that can be provided in those sentences. So if you're here and you want to look at the actual repository, so you can do a little quick read. Usually on these pages off of this reference material, it's not going to tell you all that much. It just tells you about the GitHub location, and you can click on the author of the library, that type of thing, and the latest version. Okay. So let's see, if we click on go to repository, 9 times out of 10, as far as free code that's available, you're going to be taken to a GitHub repository. Okay, it's off topic to talk about GitHub as far as how to utilize it, how to upload content to it. But usually, if you are talking about a software library for Arduino or for other tools that are out there, you're going to be taken into GitHub. Okay, this is where the wiki is what's called the documentation base in GitHub world. Remember, we talked about evaluating bugs. That's where this issues tab comes in. You want to look at how much it's downloaded. That's what this pull request has to do with. So if you click on issues here, it's going to show what those issues are, how many of them are open, how many have been closed. Okay. And so you can do a lot of, even before downloading and trying to use the library, you can find out a lot of great information whenever you actually go in deeper and start looking at all this documentation. But again, a lot of times the only way to really tell is to do a download, install it, and try and actually use the examples. You utilize the library in your actual project. So the way that you do that in GitHub, one of the easiest ways is to do a download of zip off of this green pretty button. You can do a download zip, and then you can go in and you can install that into your IDE. And I talked to you about the idea about examples. So if you click on the examples folder here, so you just start digging down into the GitHub repository, and you start looking at the way the reference material is for that particular library. That's the main point that I want to get here, as far as this walkthrough demo, is you want to see how adequate for your particular needs that library is going to perform. Now, the other one, oh, by the way, I don't think I talked about that over here with Tiny GPS. But what's nice on these reference pages is that they give you a quick overview as far as what that library is going to do for you. All right. And so this one talks about general parsing. and it works with any GPS module. That's one of the things that's nice here. And again, if you go over to the repository, you can start digging in and you can start analyzing it. Is this thing really going to do what I want? And how good of a quality is this library? Hey, so that's what I wanted to talk about there. Now let's go ahead. There's a real good quality, and I'll be providing this link to everybody. There's a real good quality. So now you've found your library that you want to use. How do you use it? How do you install and use Arduino libraries? So that's what this video is that I'm going to play for you. Okay.
Are you trying to figure out how to install an Arduino library? Well, I'm going to show you 3 different ways on how to get it done. I'll show you the easy way, and then I'll show you the manual way you can do it if you're getting some like weird library that you want to include. All right, so let's go ahead and jump right in. All right, so here I am in the Arduino IDE, and I just want to say real quick, what the heck is an Arduino library? You probably know this, but let's just cover our bases. So basically, an Arduino library is just some code that some other programmer or programmers have written, and they've packaged it up in a very specific way, and then they make it available to anybody who wants to use Arduino to use their library. That was pretty darn generous of them for them to do that. A lot of these people are extremely experienced, and they may have spent even years working and perfecting this code. And what's great about this is when you use Arduino libraries, it allows you to leverage other software developers' expertise. Because to be honest, if you want to use some complicated piece of hardware, like some electronic sensor or actuator, you might actually have to study the manuals for that pretty in depth to try to develop the software to run that appropriately, right? But luckily, all these other folks, they've already done all that hard work, and they're making that hard work available in the form of an Arduino library. Okay, so an Arduino library is code packaged in a specific way that's made available to us Arduino programmers. Okay, so that's what an Arduino library is. Here's what's interesting. The Arduino IDE, either IDE 1 or IDE 2, both of them, they come pre-installed with some libraries. So if you go up to the top of your Arduino IDE and you go to Sketch, and then you come down to Include Library, and you scroll over here, you see there's this little header here. It says Arduino Libraries, okay? So this little section right here, these are libraries that are pre-installed with the Arduino IDE. So I don't have to download the EEPROM library. I don't have to download the Human Interface Device library or the software serial. These ones, they're already there, right? So if I wanted to include those, all I would do is click it. And you know what? I'll just click this. I'll show you what happens. I'll click EEPROM. So see how I clicked EEPROM and then this little line showed up right here? So what this line of code is doing is telling the Arduino IDE that it wants you to get this file, this EEPROM.h, because this is just like a program file, right? It says, get this file, and literally I want you to paste it up in here when it's time to compile the program. So if you're pressing the verify or the upload button, right? It's going to take the code that's in EEPROM.h and it's literally going to paste it in here. Now you won't see that code getting pasted, it's going to do that behind the scenes, but that's all that's happening. It's taking this code, sticking it at the top. All right, okay. So what we just did here is we didn't install the EEPROM library. We just included it in our sketch, right? So now in this sketch, I can reference functions in the EEPROM library. But if we want to actually install a library into the Arduino IDE, one that didn't come prepackaged with it, then we need to pull in that library from usually the internet, right? And there's lots of different ways you can do that with the Arduino IDE. Okay, but let me just show you real quick. I'm going to go back to Sketch, and I'm going to say Include Library. See this section down here under Arduino Libraries where it says Contributed Libraries? When you pull in a library from a third party, from an outside source, they're going to be listed here, right down here. So these, you can see I've got a ton of different libraries in here. Probably not much compared to a lot of people. Some people probably have a ton. Maybe you don't have any right now. You're just getting started. Doesn't matter, right? Okay, so when we import a library, it will show up here under Contributed Libraries. So, okay, how the heck do we import a library? Well, I want to put a quick pause on this, okay? Because, and this is going to annoy you, and I'm not trying to be like super annoying, as my kids would say, but here's the deal. In life, sometimes you need to do like pre-work before you do the work. Okay, so like the work itself is super easy, but what really matters is the pre-work, like setting it up, right? Okay, so what am I talking about? Well, before you just willy-nilly start importing libraries into the Arduino IDE, you need to do a little like research on the library, right? Like, why are you getting in the library and which one are you getting? So maybe, for example, you have a project and you want to include an accelerometer into the project, okay? So what you might do is you might just like, oh, I'll just randomly import any accelerometer library, right? A better approach, though, is to do a little research on which accelerometer library you want to pull in. Or maybe you already have the part number, like the exact accelerometer you want to use. So maybe you would Google like Arduino library for, this specific accelerometer, right? You might get like multiple options. And then what you want to do is like compare which one you think is going to be the best. Now, as far as like making that decision, that's kind of beyond the scope of what we're going to talk here. If you want to learn about that stuff, check out programmingelectronics.com. We've got training that dives into all that kind of stuff. But you just want to do the pre-work. Okay, so now let's say you've like, okay, I know what library I want to get. I'm going to go ahead and import it. So here's the easy way to do it. And first I'm going to show all the ways in Arduino IDE 2, and then I'll show you in Arduino IDE 1, which is still, both of them are still used extensively. Okay, over here on the left, there's these icons. And all you have to do is click the one that looks like a bookshelf. Now, before you do that, what's interesting, a little known Arduino Easter egg, if you zoom in on this icon, they've made some interesting selection of books here, Anyway, okay, so you click this, and this pops out, this little shelf pops out, and you see there's this huge list, right? So this huge list right here are all the Arduino libraries that third parties have contributed to the Arduino ecosystem, essentially, right? And, like Arduino has a mechanism by which people can contribute libraries. In fact, I contributed one. Let's see if we can find it here. ChatGPT. I think there it is. ChatGPT by Mike J. See, so I've already installed that library. But anyway, there's a mechanism, and it's actually pretty easy to contribute a library to the Arduino ecosystem. Anyway, so what you do is you search for your library. So let's say I'm just going to search for accelerometer. I'm not sure I'm spelling that right. Okay, here we go. Now see that this list has been filtered. That's pretty common. And I've got this massive list of different libraries for, looks like, yeah, most of them are for accelerometer stuff, right? So I've got to know, hey, which one do I want? Now, let's say I've chosen the one that I want, and let's say I'm working with this LSM60SOX. Okay, all I'm going to do is click install. Like, that's all I got to do. Now, notice you can pick the version. That's kind of cool. I think it defaults to the most recent one, okay? You can click more info. This will take you to like the GitHub page where this code repository is hosted. But I'm just gonna click install. And then down in the right-hand side, it says, hey, I'm installing this, and it gives you some information on the output. Okay, and that's like the easy way to do it, all right? Now, what actually happened though? I pressed some buttons, like, I don't know, threw some text at me, like, I don't know what actually happened. Okay, so here's what happened. The Arduino IDE, it went out to the internet and it downloaded a file. It downloaded some code, and then it stuck it in a very specific place. And I'm going to show you right now where that place is. Okay, so there's this concept with the Arduino IDE, and it's called the sketchbook folder. Okay, now what I'm about to tell you is not esoteric in any way, shape, or form. This is actually really important for you as you learn how to develop Arduino. So I'm not talking about like some weird, like obscure thing. Okay, so the Arduino sketchbook folder is where all the files that you write, all the Arduino programs you write are going to get saved in this folder, okay? And this folder is usually under like My Documents Arduino, okay? So that folder called Arduino in my documents, that's like the default location, that is the name of your sketchbook folder. And to check this, all you do is you go to settings or preferences, all right? And right here, it says sketchbook folder location, and you can see mine is in users, Michael Chach, documents, Arduino. So, it might be my documents, whatever. So this is my sketchbook folder. So now let's go to this sketchbook folder, all right? So I'm just gonna go ahead and I'm gonna take a look at this sketchbook folder. Okay, so here I am in my sketchbook folder. So Arduino is the name of my sketchbook folder, probably is the name of yours too. Again, that's the default setting when you install the Arduino IDE. And so I'm in my sketchbook folder, and inside everybody's sketchbook folder, there is a folder called libraries. And this folder right here is the magical place that code that you just downloaded, that the Arduino IDE downloaded for you, this is the magical place that code is going to go. So, hey, let's go ahead and take a look at this mysterious place. Okay, so what was that thing we downloaded? What did we say it was? Arduino LSM63S. Arduino oh, bam, there it is. Okay, wow, that's cool. All right, so now I'm going to open this folder. Let's take a look what's in here. Okay, so in an Arduino library folder, you're going to have some specific other folders. Okay, so one very common one is the examples folder. And in the example folder is where they have some example sketches. Okay, so they usually have an example folder, not always, but usually, and here will be those example sketches. Okay, so another folder they might have in here is called SRC. That stands for source. That's like where the source code is. Okay, so when you click this, in here, this is where they're going to have a .h and a .cpp file. So CPP, that would stand for C++, and .h is the header file. Okay, so these are just like code files, and they are what are specifying like the functions and the code that essentially make up that library. Let's look at some of these other files here. All right, so this one, keywords.txt, this keywords file, this identifies which words that the library author want to be highlighted in the Arduino IDE. Like, how some of the words in the IDE change colors, they're like keywords and stuff. Well, you can do that for contributed libraries. You can make like the word change color, which is pretty cool. All right, so they would do that in keywords.txt. Okay, and then there might be some other stuff in here. It looks like they've got some documentation in here. So this is kind of interesting stuff. Now, importing an Arduino library into Arduino IDE 1 is just as easy. All you do is go up to Sketch, Include Library, and you click Manage Libraries. And what it does is it's going to open up a window. So instead of some like shelf coming out of the side, it just opens up a window here, and this is your library manager, and you're going to do the exact same thing. Usually it'll kind of like update your list of installed libraries here, and all you're going to do is type in what you're searching for, and then it's going to filter them just like Arduino IDE 2.0. So same exact process. I'm just going to wait patiently for these libraries to update. All right, so I can just search for Excel, and now stuff will come up for accelerometers. Okay, and then you would just click install, same exact thing. Now here's what's really cool. Arduino IDE 2 and Arduino IDE 1, you can have them installed on your computer at the exact same time, and they share the same Arduino sketchbook folder with that same library folder. So if I installed it on Arduino IDE 2.0, it's going to be in when I go to Arduino 1.0. Same exact thing. Okay, so I just showed you the easy way of how to install an Arduino library. So let's say we installed that library. Now we both know, like, hey, where did that library actually go? Well, it's just in your Arduino sketchbook folder under the libraries folder. Okay, so that's where the code lives. Now, what if we want to actually like add it to our program and start using it? Well, then we have to include the library in our sketch, just like we did before. So now if you go up to Sketch, Include Library, now we can go to contributed libraries, right? Because that library we looked at, we added it, right? We can come down here and let's look, what was it? It was called Arduino. Here it is right here. So I'm just going to go ahead and click that, and bam, it just inserts that right there. Now, that's just a little like handy helper thing, right? You don't actually have to do that. Like I could just manually type out, include, and then, I could type this out, right? There's nothing magical about going to Sketch, Include Library, and then like pressing this. It literally just inserts the code that you need for, or that line of code, right? So you could manually write it out if you wanted to. Anyway, it's just trying to like save you some button clicks, maybe save you from mistyping it. Okay, so that's that. So now you know how to install a library and how to include it, and then you can actually start using the code in here. All right, so here's the deal. Sometimes you might have to install an Arduino library manually, okay? Now, it's pretty darn easy to do, and I'm going to show you 2 ways to do it, okay? Now, the reason you might have to do this is because maybe the third party that made the code, maybe they have not submitted it to Arduino yet. So that could just be one of the reasons. And so when you go searching for it, it's not in that library manager. You're kind of like, hey, what gives? Well, you're just going to find it somewhere else, right? Like maybe it's on their website, or maybe it's on GitHub. It just hasn't been submitted yet. So let's talk about the first scenario. If you have a zip file for the library, there's a way to install it from zip. So let me give you a concrete example here. So here I am on GitHub, okay? And GitHub's this huge code repository, all right? And what I want to do is get this Morse code library up here, okay? And let's just pretend that, hey, this is not in the Arduino ecosystem. All right, maybe it is, I don't know. So I just going to click this code button, and I'm going to say download the zip file, right? Because you got to have for this first method, you need to have a zip file. So now I'm going to download this file, and it really doesn't matter where you download it, as long as you know where you download it. So I'm just going to download it to like my downloads, right? So it's called Morse Master. I'll hit save. Okay, so now I have a zip file. I'm not going to unzip it. I'm going to come over to the Arduino IDE, and I'm going to go to Sketch, Include Library, and then I'm going to say Add Zip Library. I'm going to click on this, and it's going to open up a window, and it's going to say, hey, look for this library. So I think I saved that in downloads, and what did we call that? Morse, here it is, morsemaster.zip. All right, and then I'm just going to click open. Okay, and then it's saying, hey, I'm processing this. It says the library's been installed, successfully installed that library. Now, adding a zip file library using Arduino IDE 1 is the exact same thing. So all you do is go up to Sketch, Include Library, Add Zip Library. Same exact process. Okay, hey, that was pretty easy, right? That was a manual install. But you know what? Let's do this. Let's go to Sketch, Include Library. Where should we find this? That's right, we should find it under the contributed libraries, right? Because we had to install this. It's like doesn't come pre-installed. Let's see if we can find Morse. Okay, there it is, Morse right here. If I click that, it should include Morse. All right, that's cool. Well, hey, let's just triple check. Let's see if that folder is in our libraries folder in our Arduino sketchbook. So I'm gonna go look in there again. All right, so here I am in my Arduino sketchbook folder. I'm gonna come down to libraries. All right, here's all the libraries. And I'm just looking around. It was called Morse, right? So oh, there it is, Morse. And what files are in here? Okay, well, notice here, so we have an examples folder, okay? And we've got the keywords, cool. And then we have morse.cpp and morse.h. Those are the actual code files themselves. Like, okay, sweet. So that's one way to manually install a library. Here's another way to do it, and you don't even use the Arduino IDE, so check it out. What do you think I might do here? I'm curious, what do you think I might do in order to put another library, make another contributed library available? All right, so check it out. Here's another library. It's called Timer1. Okay, so here I am again on GitHub, and I'm going to go ahead and download this Timer1 library. Let's assume that it's not available in the Arduino IDE. All right, so I'm going to just go to Download Zip, and I am going to save it right in the Arduino sketchbook folder. All right, so I'm in Arduino. I'm going to come down to that libraries folder. It's in here somewhere, right? Here's libraries. Okay. All right, so here we are in the libraries folder, and I'll just click save. Okay, so now I have saved this. So let's go to that folder now. So here I am again. I'm in my sketchbook folder, Arduino, and I'm in, it looks like I'm in the libraries folder. Here we are, right here. Here's the libraries folder. And what did we just save? We saved Timer1. So I'm going to come and I'm going to look for the zip file that I did. Here it is, right here, Timer1. Now, it looks like I already have that in here. I'm just going to move that puppy to the trash. Okay. So now what I'm going to do is I'm going to unzip this. Now, I happen to be on a Mac, so I can just double click this and it'll unzip that for me. Okay. If you're on a PC, I think you right click and, do like WinZip, something like that. Okay. Now, once I've unzipped this file, I can get rid of that zip. So I'm just going to go ahead and move that to the trash. Here is this folder right here, timer1 master. And when I open this, notice we've got timer1.cpp and timer1.h. Now here's the dealio, and this is massively problematic. The name of this folder and the name of the .h file that you're going to first call need to match. Okay, so notice that this one says timer1-master and this one just says timer1.h. Well, you have to change the name of this so that they match. Okay, so I'm just going to get rid of that. I'm going to change it to timer1. Now they match, so I had to do that manually. Notice when we use the Arduino IDE, you didn't have to do that. So anyway, so I did that. Now I'm going to come back over to the Arduino IDE. Now, before your Arduino IDE will show you that library in the contributed libraries, you need to close and reopen the Arduino IDE. So I'll just do that real quick. And now when I go to Sketch, Include Library, scroll down, I should see timer1. And there it is. Sweet. Okay, so there's 3 ways to install an Arduino library. Now there's one little trick I want to show you. We've been installing these libraries, and do you remember that examples folder that we saw in several of those libraries? Check this out. If you go up to File, Examples, and you come down here and it says Examples from Custom Libraries, this is where you're going to find those example sketches that were included. So before we had Morse, right? So this serial example is an example of how to use the Morse library. And then what did we do? We did timer1. Look, there's 3 different examples here on how to use this timer1 library. So that's a really great place to start when you're trying to learn how to use the code in one of these libraries. Now, if you're really into this Arduino stuff and you want to just accelerate.
Okay. All right. So enough on that, guys. One little thing I want to share. Let's go ahead and open up the Arduino IDE. This video that we just watched was a little bit dated as far as the current version of the IDE, which in my case is 2.3.5. If the information that he reviewed with us is in a slightly different location. So if you go over, in this case with this version, and you do Sketch and you do Include Library, and we do Manage Libraries, or you can add. So I believe that was just a little bit different as far as the functional location that he showed. The other thing, as far as all of the examples are concerned, that's off of definitely a different location. If you go over here to File and you do Examples, so the built-in examples are here and custom libraries are over here. So that's the locations for that. Okay. So the only other thing that I want to talk about regarding libraries for today is just some general basic guidance that I've got for you. Start with defining your goals. What is it that you want to do with a particular library? Do you need to have board support, sensor support, or say like what we were just seeing there in the video? Arduino timer, additional Arduino timer support. Do you want to do that? So that you want to identify your goals. What is it that you want to do with it? What is it that you're ultimately looking for? And of course, knowing the exact part is paramount if you want to interface to something very, very specific. And look at how and evaluate your multiple options. We've already talked a little bit about that in the video. He talked about that a little bit more. And see if it's in a cursory, in a high level view, looking to see is this going to be a satisfactory library for what it is I'm looking for. But many times that front facing view of a library doesn't give you the whole picture. You need to, regarding the documentation, the examples. A lot of times you just literally have to try it out. I already talked about this before. So you need to do a physical evaluation that way. What if you don't find a library for your particular part? What if it's something that is relatively obscure, something that's not supported. Well, you can write your own library. And there are lots of examples out there, tutorials about how to do that yourself, whether or not you use GitHub or the actual Arduino community support steps to actually get that library into the system. You can literally write your own. And you want to say that the part in the library just don't work, or you don't feel skilled enough to write your own library. Well, in those kind of situations, you could evaluate, you could go out and you can buy yourself another part that has similar functionality, and looking at the pre-written libraries that are available for that, and basically just kind of start all over with that function. So you could always do that as well. So knowing all this, when shopping for new parts and boards, it's best to not only find the part that you want, but also analyze the available libraries for it, making sure that you got a good pairing of that before you actually do any purchases. So that's just some good hardcore advice there. Okay, so we've got time for, why don't we go ahead and do like a 5-minute break, guys? And then we'll come back, and then we'll move on to the next step that I wanted to do with you today. Okay. Oh, excuse me. Well, I set the timer for 10, but we'll let it go until for 5 minutes. That way we can take a bio break, a stretch break. Okay.
Oh. And a 5-minute break. They just started a 5-minute break. So I want to ask her, she showed us several shields, but what do you do if you need to use 2 shields at once?
Yeah,
Are they designed to stack, or are
some will, some won't.
Some
I mean,
won't.
it all depends on if they're relying on software to stack nicely. If they're using SPI, then maybe not as bad.
I'm trying to think through, remember I bought that large number of bags from the Stanwood swap meet that have something to do with Arduino. And a lot of it was sensors and actuators that used little 3-pin connectors and shields that had rows of 3-pin connectors and stuff like that. But I didn't get any 3-pin connectors. So
Oh, those could be like PWM.
well, I don't think that's what it is, though. It's like they'll have an LED that has a 3-pin connector, or what do you call it? A temperature sensor that has a 3-pin connector. They had a whole standard of that way earlier on. Like, this is in the early 2000s, and I don't know how much of that stuff is still viable. I mean, it's probably still works, but I don't know if you'd want to use it.
Yeah, but for stacking shields, you really need to examine spec sheets of both of them and make sure.
Oh, so one of the things I got in there, I think, is a device that allows you to stack shields.
Oh,
So not on top of each other, but side by side or something. I'll have to look at it more closely.
yeah, those are usually for like troubleshooting
Mm.
and stuff like that. A lot of times when you stack them, you just lose access to some things that on the surface of the board. So it just doesn't work out
Doesn't
as well as it would hope. Gotta Google Scholar. To do that there. I got my robot finished yesterday.
Yeah, you mentioned that. Are you gonna be able to bring it on Thursday?
Okay, guys, time is up. So I think what we should do here, in that we're running, I've gone over a little bit on time from what it was my original plan. I think what we should do is wait until next month and we'll cover the other major education point of the basics of hardware interfacing. We'll start our session next month with that and then move on to our other stuff that we want to do for the project because I want to have ample time to discuss the project that I am proposing for all of us to work on as a group. I know that there's been some interest in that in the past, and so I want to actually get that launched for everybody. So the group project that I am going to propose that we all work on together independently, but as a group come together and work on it and support each other is the idea about taking a inexpensive, preferably an inexpensive remote control vehicle, either a car or a truck or even a tank type vehicle, and convert it to Arduino control. And it's best that we find cheaper RC control. I'm talking about standard remote control industry, either truck, car, or tank. And what I'm going to recommend is that whenever you find something that is right for you, that you buy a quantity of 2 of those. And I don't recommend that you go with something that is used. In other words, something that you find, say, on eBay or something like that. Instead, go with a regular retailer that is has good decent quality and at a reasonable price point for you, and that you do a purchase that way. And why did I choose this particular project type? Because it's customizable. It's customizable to us as a group learning project, but also individually what our goals are as Arduino experimenters, the way that we want to learn and grow individually with our Arduino skills. And it's a multi-directional project. In other words, you can do so much just based on that movable platform. And even the idea of turning it into a robotic rover type of experiment and project. So there's lots and lots of opportunities for us to take advantage of here. And there's a huge, so what I'm going to do is I'm going to do a little show or a little review here online for the types of vehicles that I recommend that you look at. Let's see. So let me go ahead and pull up some of the URLs here in my browser. Okay, stop. Okay, let me go ahead and segue on that here. Let's see. Okay. Okay. So basically, oh, sorry guys, do share screen now. Um, so basically, remote control vehicle wise, I'm literally talking about something where you got your handheld joystick or other remote control transmitter, and that you have your remote control vehicle, whether it's a car, truck, or tank, and that you are remotely controlling that vehicle. That's what I mean by an RC vehicle. And really, these vehicles for RC standards come in a multiple size range. They come in a scale of 1/5 all the way up to 1/28. I recommend the cheaper variety, especially for those who are not real highly skilled for electronics and for programming. Because the reason I say that is if you blow something up with a motor or whatever, fry something on the board, etc., it's not a huge money loss that you can go and you can recover and you can buy something new. So basically, as far as these types of vehicles that I'm speaking of, you can get cheap stock run as is vehicles. The typical sizing is a 1/10 or 1/16 RC standard sizes. And these are not built for any modifications by the user of that product. Here's an example of one of those cheaper, at in this case $40 if you were to buy from exhobby.com, this particular product. But it comes with the stick, the transmitter. It comes with batteries in this case, and of course then the actual stock vehicle. And of course what's nice about these is that you can steer them, you left, right, go straight, backwards, all in a remote control fashion. So here's one sample of the cheaper variety, run as is type vehicles that are out there for perusal and potential purchase. Then there's another style of RC vehicles that are for what I'm going to call the serious remote control hobbyists, where they are very, very configurable. You can literally uninstall a hardware piece that's on the product itself and substitute another RC standard part, say for instance an ESC or a receiver board, and besides all the hardware like springs and tension configurations, all that kind of thing. That's what I mean by it's a hardcore type of product for the real RC enthusiast. And you can do all sorts of upgrade options with a remote control vehicle such as this. And here's an example of such a product. Traxxas is one of the main retailers and manufacturers of such products. So this is just something for your reference. I don't necessarily recommend, especially from the money standpoint, that for this particular group project that you go with something like this, okay? Unless you're real serious about moving your projects in that direction. The last thing, as far as what I'm going to call a remote control or project platform type of product that you can buy is more directly for robot builders. And this here is a sample of such a product. This is designed specifically for robotic use. So this is not this usually these products don't come by default with remote control transmitters and receivers, but they are great for the more skilled embedded boards like Arduinos and also electronic enthusiasts. Of course, as we're going up the scale here, we're going up the scale in functionality and also in price. But what's so great about a product like this is you're away from the RC industry standards of included parts. So the specs are easier to disseminate and work with to make sure that you're getting comparable. Say the motors that are on this particular platform, they're easier to match with robotic type motor controllers, motor controller shields for Arduino, all that. And so this is a comparable product for that. So these are just types of things that I recommend that you look at. And I recommend option number one. Okay, because the interfacing is easier. If you blow something up, you're not out a huge amount of money. And also because the motors and the technologies that are on these cheaper platforms, they are not as sophisticated. They're easier to interface with, and mostly because the motors that are on these particular types of platforms, they're not as resource intensive, they're not as expensive, and they don't need as much current and voltage needs like the higher end Links Motion type of platform vehicles, all that kind of stuff. So that's another reason to go with something lower end. Okay, besides the cost. And I recommend, so one of the things we've been talking about throughout today are motor controllers. And I recommend that for this project that one of the first initial beyond the platform purchases that you make is to get a compatible motor controller shield, motor controller board that will work with the motors that want two or more motors that are on your platform. And I recommend that you start shopping for this after you've made your vehicle purchase for obvious reasons. You know, you need to open up the box for that RC vehicle. And you need to investigate what it is that you've got in that package deal that you purchased. You will likely need a two motor DC motor controller, one motor on that shield or driver board will take care of the rear drive motor. And then the second controller outlet, IO port, will interface with the front steering motor. Now, usually on these cheaper RC vehicles, it looks as though for the steering motor that is likely a servo motor that's on there or a stepper motor, but usually it's the cheap DC motor alternative. It's packaged differently with a custom gear drive reduction box that they've got attached onto the platform. And so that's why I say the shopping for a 2 DC motor controller board is usually warranted, because usually on those cheaper platforms, you don't have servo motor to worry about for the driving, nor stepper motor for driving. Okay. And then you also want to be shopping for a motor controller board that supports what's called brushed DC motors and not brushless. Those are the typical DC motors that are out there. Okay. And the way that you tell, again, whenever you open up your product box and you start unscrewing off the case, you start looking at the PC board and the actual soldered connections that go to it for the motors and whatnot. The way that you tell if you've got a brushed versus brushless motor has to do with the number of wires that are actually come from the case of that motor. So if you're talking about if you have 3 wires out of that motor can, that means you've got a brushless motor. If you only have 2 wires, that means you have a brushed motor. And invariably, brushed motors are easier to use and they're easier to control, cheaper to control, okay, than going with brushless. So that's right there is a positive with going with one of these cheaper RC vehicles. Okay. You want to, for the specs of the boards, you want to start with, because what's bad with these RC industry vehicles, like what we're talking about here, is that everything is RC standards. They're not geared towards the Arduino user, nor shopping for extra parts like sensors or controller boards or shields. So you have to start from a very much of a lower or a higher level of detail rather than the low level that we as designers need to look at. So you need to start with the battery pack voltage for what comes for your vehicle. That's one of the main specs that you need to look at and evaluate for your motor controller. And usually the small and then you want to identify what that. Okay, so typically for the smaller smaller vehicles that are the cheaper RC type, they either need a 6-volt battery pack or a 7.2 volt battery pack. Okay. And so it's that standard voltage that usually, invariably 9 times out of 10, is what the actual motors on that platform need for their power supply. That's the DC motor voltage, 9 times out of 10, that your motor controller board needs to use. Okay, so that right there is key point number 1 in evaluating your motor controller. The next thing that you need to look at is the current needs, the amp weight ratings on those motors. Okay, so depending on the remote control size of the vehicle, the typical, because there's really no way, I mean, unless the RC battery pack is an anomaly, 9 times out of 10 they don't give you the information you need for the amp requirements on those motors. So usually the smaller RC models will require an up to a 3 amp motor controller. For a medium-sized model, in size, now we're going from small to large, a medium-sized vehicle requires maybe up to 13 amps. Now this is really grandiose max amount here. The larger models will require 20 to 30 amp ratings for the motor controller boards. So that's just kind of a general gauge. Whenever you're going and you're buying these motor controller boards, you always want to buy something for your board that is overrated for what you know or think that motor is really going to use. So in other words, you're safer going with something larger, okay, for the amp rating on that motor controller board. Okay, now to be on the safe side, you can always do actual current readings when using the remote control vehicle. In other words, using it in a stock fashion. Okay, so what you can do is you can put your vehicle up on a motion control stand, and you can cut the positive supply wire line that goes from the battery source to the PC board that is actually mounted on the remote control vehicle itself, and then insert a multimeter to read the actual current draw over multiple use scenarios. That's one way of more precisely judging the amp requirements. And so a good starter site for actually doing some shopping for brushed DC motor controllers is looking at a distributor like robotshop.com. And they have a huge selection among other retailers as well of various configurations, voltage and ampere requirements for the motors themselves, and overall configurations of the board, in addition to a wide range of actual pricing of these boards. So I recommend that you start there, that you, number one, that you get yourself a great platform of choice, probably buy in a dual, in a pair mode, and then actually do your unpacking of your product, dig in and see what your configuration is for the motor designs, etc., and then go shopping for a motor controller board. And as I say, 9 times out of 10, you're going to need a motor controller board, either two individual, in other words, one DC motor per motor controller board, or one motor controller that supports two DC motors. So that's the type of thing that I recommend that you start looking at after you've made your purchase. So let's go ahead and stop share. So it basically the learning outcomes that I see for this particular product are wonderful opportunities for all of us to understand, number one, how remote control vehicle systems and Arduino based control can work together, and build and integrate real-time motor and input systems in with your design. We will be learning about wiring and coding and testing a actual Arduino converted RC vehicle, and collaborate as a team to solve engineering challenges. So let me just do a quick walkthrough, a quick show and tell in my camera view here. I already have a starter for this project going. Okay, I have an old Radio Shack, small scale truck that I'm starting to convert. And this one has just as I had been describing before, it has a rear drive small DC motor. We're probably talking no more than 5-6 volts for that drive motor, and comparable for the steering system, also DC motor. So I took that apart. I already constructed a wood plank deck to be starting to mount a bunch of stuff onto. And so this is a great opportunity, as I say, to be experimenting program-wise and electronic interfacing-wise, to actually be utilizing our Arduino in a project fashion. What's great also with these platforms is that, like in the front, the rear of the vehicle, etc., there is custom build area to be mounting sensors and all that kind of stuff. So this is a very, very much of a flexible type system. And then, of course, here's the RC antenna. So that's what I kind of wanted to cover today, as far as announcing of the project that I'm proposing. Okay, and so what kind of? I know that this has been a intense session again, but all the resources, etc., and the recording will be available to you today onto YouTube and onto Discord. So what kind of questions or feedback do people have? Oh, and then I'll go ahead and I'll take care of the chat here as well. Let's see here. Where is that?
So Donna, you haven't talked yet about um, uh, if if you could use more than one shield on the same Arduino at the same time.
Oh, yes, yes, you can.
Like that.
Yes. Yeah, they have to. So a typical way that shields are used with Arduinos, I didn't mention this, is that literally you've got a stack, like a dinner plate stack, that grows from the bottom up. And of course, you need to make sure that everything is compatible with everything that's down below it, both for the Arduino and for the other shields that are in the system. And so, yes, it's typical, provided that you've got ample I/O on the Arduino controller itself, or you've got things, or you've done some sort of I/O expansion from your Arduino itself. As long as you've got the I/O available, and of course the battery power supply to handle all that, you can build out a full system of all different types of sensors, of all different types of boards, and and shields that all formulate your system. Regardless if those shields are literally physically stacked on top of one another or not. Really, practicality wise, beyond a single shield being physically sitting on top of an Arduino, for the practicality, it's not necessarily a smart idea to keep stacking beyond that one. I mean, unless the shield is very unique, where it's easy from the outside view of that shield to access all those ports and functionality that shield is providing. Usually, it's smarter to devise a system where you've got the shields mounted off of off of off board, so to speak, of the Arduino itself, and mounted in a separate methodology. Does that answer your question or your comment, Doug?
Well, I've heard that there can be incompatibilities between shields.
Right, that's
that-
true.
That's difficult to
Right,
make
and
sure
that's
that the
yeah,
shields are going to work together.
right, and so that's what it is. I was advising before, is that that is basically that you look at this from a system designer's standpoint. You kind of define your overall goals in this case, for your remote control vehicle as a whole, and then you start breaking things out, identifying the individual boards and parts that you want to connect in with your Arduino of choice, and then you start doing some real deep dive research whenever you find out what it is that you really want to do functionality wise. Is that then you start matching those functions in with a set of boards that support those functions, and most importantly, that will allow them to interlace and coexist together as separate entities, but all part of your main system. And then also, also consider too that if you've got a real complex system, which isn't necessarily warranted for this sample project, you can always have more than one controller board that make up your system, and and then kind of have multiple multiple things going on within the system with multiple different controllers. That's a more advanced topic, but that is one way of solving that incompatibility, is to have things segmented that way. But yeah, the research and the analysis is very, very critical right from the get-go with figuring out what you want to do, finding boards and libraries that fit your needs and that will ultimately work together. So And as I say, what we'll do in July is we'll start digging into all of this at a deeper level, for starting to actually build this remote control to Arduino vehicle. We'll get into a lot of the deep dive specifics on that. But firstly, we'll finish off what I had originally planned on for today of looking at some basics for hardware interfacing. Jacob, you've got your hand raised. Go ahead.
Oh yeah. You were talking about libraries, so you think for this remote control vehicle, we could maybe it'd be even necessary to make our own library for that?
Yeah, that's possible, but usually, for especially in the well, for this target project, is that there's so much out there for motor control support that's already out there, for sensor support, and overall needs and desires for what it is that we want to put on this vehicle. 9 times out of 10, you won't have to write something completely from scratch, because these are recipes and uh, yeah, recipes that are out there that are very commonplace, and that other Arduino enthusiasts and even remote control enthusiasts have researched and have already got implemented for us. Um,
Okay.
so in other words, what I'm recommending is that you don't necessarily worry about at this stage having to write your own library. I was just giving some basic education that is always an option. That if you have
Okay.
something that you're really in love with for the hardware board and the Arduino, and there just isn't a library out there that is going to fit the need, then you can always write your own. I was just talking about more or less
Okay.
an addition, an additional things to be considering. That if
Yeah.
you really want to stick with what you've got, and there isn't the library support, that you can always do that.
Okay. Yeah, I was just interested actually making my own library, so that kind of
Oh
stood
yeah,
out to me. So
right.
it's not
Yeah,
like you said, it's not necessary, but it is, you could
right,
definitely do it.
right. Yeah,
Okay.
yeah. It's a fun learning project anyway. Writing your own.
Yeah, exactly.
So okay. So anything else for the good of the order, so to speak, today that people want to talk about? So you've got an assignment going forward here. You need to look at and figure out what you want to do for your platform of choice for working with this project, and then you need to take it apart, start looking at the compatible motor controller boards or shield that you're going to want to purchase, and hopefully get both of those taken care of by the time that we meet again next month. So lots to look at and experiment and learn about. And like I say, those references, etc. Oh, I guess I could put that stuff into the chat. Um, as far as so that you've got stuff right now, today, right at the end of this call, all of the references that I mentioned. Here's the set of URLs. Okay, now let's see here. Okay, so there's one set right there. I see. So did that come through okay as far as on the chat view? I just sent a set
Yeah.
of okay, so okay, good.
Yep.
Let's see. And then here's the second set. So a bunch of reference documentation today. Okay. Okay. So is that all? So go ahead and save the chat. And anything else that people want to discuss or contribute?
We might want to mention, in case people didn't happen to notice, that Seed Studios is spelled with 3 E's.
Oh, right. That is true. Yep. Yep. Yeah, it's not just as it sounds. It's a different spelling. Yeah. Very good. Thank you, Doug, for mentioning that. Okay, so anything else? Did everybody grab the chat that they wanted? Okay, so I think we'll go ahead and stop the